Here's a related rates problem. How do we know that it's related rate? We're beginning to talk about something being increasing. If I can get my pointer correct here. So we're talking about something that's increasing, and we've got time involved in it here. Okay, so the cube is expanding so that its surface area, I'm just going to use A for surface area, dA dt is 9 square root of 2. Alright, now it's a cube, so we need to think about a cube means all the sides are the same, so that means we've got x cubed, and that also means the area of each one's a square, and we've got 6 of them here. Okay, how fast is the volume increasing? So we're looking to find dV over dt at the instance when the surface area equals 108. Okay, well, let's see, what do we know here? We know we've got dA dt, so if we take the derivative of this, we get dA over dt equals 12x dx over dt. Alright, and we know that this is 9 times the square root of 2 equals 12x dx over dt. So then we can solve and get that dx over dt is 9 root 2 over 12x, which is 3 root 2 over 4x. Now that's a little different from what we're accustomed to seeing things, but it will work for us here in just a moment, because we also know that the area back up here, we know these two things are equal. The area is 108 and equals 6x squared. So if we go down and solve that now, 108 equals 6x squared, we can find out that x squared equals 6 will go 118. So x is the square root of 18, which is also known as 3 root 2. Alright, so now if we plug that in up there, we can find out that when x is that number, dx over dt is, what did we say it was? It's 3 root 2 over 4 times x, which is 3 root 2. So we get that dx dt is 1/4. So suddenly now we know what dx dt is, and we know what x is, and we just need to know what v is. So let's come over here and take the derivative of v. Dv over dt equals 3x squared dx over dt. Well, we've determined that x was 3 root 2 and dx is 1/4. So we can say that's 3 times 3 root 2 squared times 1/4. And if we do that, we get 3 times 9 times 2 in the numerator, all divided by 4, which becomes 27 over 2 for the rate of change of our volume in this problem. So that's what our dV dt is.